Hey, welcome to AAA Bio with Andrew and Aziz. Today, we're going to be talking about phantom limbs and neuroprosthetics and how they can improve the quality of life for people who need them. People have been missing limbs since the earliest of times. A hunting accident, birth defects, war. All of these are just a couple of reasons that you could be missing a limb. Luckily, we've been developing solutions to this problem since over 2,000 years ago. One of the earliest prosthetics was a wooden toe, presumably used by an ancient Egyptian noblewoman. This is Ambrose Père, a French barber in the 16th century who suggested that limb amputation was life-saving in some cases. He would go on to develop prosthetic limbs as a solution to patients missing extremities. This would lead to the development and research of prosthetics and their uses for all limbs. As a combination of science and engineering, the prosthetic limb is not just a tool. It is a reimagination of the human limb, one that allows a person to regain some of the functions they lost due to their tribulations of a lost limb. But enough about regular prosthetics. Let's talk neuroprosthetics. In order to regain the confidence in their limbs, the prosthetic of an amputee must match their original limb. This includes both the ability to withstand the demand of the user and also relay information to the user. This is where the neuro part of neuroprosthetic comes into play. It all has to do with how much the brain trusts the artificial limb. Basically, it's a mission to trust the limb. In a research test by Hamid, Breanne P, Christie, and Ronald J, Triolo, sensory neuroprosthetics were tested to improve postural stability in the case that one or more of an amputee's sensory inputs were compromised. Individuals who went through lower limb amputations began to lose confidence in their walking speed and their ability to travel through uneven terrain. The researchers tested 3 different inputs that were believed to help the individual's balance. These 3 inputs are visual sensory, vestibular sensory, and somatosensory. 2 patients, one being 67 years old and the other being 54 years old, who were classified as non-fallers, volunteered to become test subjects for this experiment. The researchers tested whether stability was kept when visual, vestibular, or somatosensory sensors of the amputee were disrupted. In the conclusion, they have found that the stability was kept with the neuroprosthetic when each of these sensory inputs was compromised. This means that the sensory stimulation obtained by the neuroprosthetic was beneficial to the test subject and allowed them to keep balance. We can assume that these test subjects became more confident in their ability to walk and stand, and that the idea of fully replacing a lost limb at full functionality was becoming more and more of a reality every day. Today, 84% of people with lower limb amputations choose to wear a prosthetic which assists them in walking, absorbing shocks, bending the knees, and stabilizing their stance. Around 70% of people who have gone through lower limb amputation have come to face the issue of phantom limb pain, known as PLP. PLP is a painful sensation at the area of amputation. While the limb may be gone, a pain that some describe as excruciating continues to persist. A study was done to see if the addition of a neuroprosthetic would lead to any positive result when relating to PLP. The researchers attached a prosthesis which provided electrocuteness feedback to the individual's thigh whenever he or she touched the ground with their neuroprosthetic. This was done in order to mimic a somatosensory response amputees would normally lack in regular prosthetics. The test subjects were then put in obstacle courses with uneven terrain and 2-minute walk tests in order to test the prosthesis. They completed both tests using prosthesis with and without the feedback system, and were later interviewed about their experience. Most responded that they preferred the prosthesis that returned a somatosensory response, and the researchers then came to the conclusion that the prosthesis with a feedback system increased the individual's confidence in walking and reduced the occurrence of PLP in the amputees. The research of neuroprosthetics has been very fruitful. The development alone has increased the quality of life for amputees significantly, and the common trend leads us to believe that neuroprosthetics are overall superior to regular prosthetics. And we're right. Tomorrow will always be a more technologically advanced day than yesterday. Those who have used neuroprosthetics have shown an increase in confidence when walking, more stability when walking in uneven terrain, and a reduction in phantom limb pain. As advancements in prosthetics grow, we come closer to creating something great for mankind. Or perhaps destructive. Special thanks to Dr. Price and Bio 351 class for listening in on this podcast, and hopefully you learned something interesting today, and don't forget to like and comment. Thank you.